Have you ever wondered how electrons are arranged inside an atom? In this video, I will be teaching you how to write the electronic configurations of elements. My name is Adrenaline, the Bazooka Prophet, CEO Adrenaline Online Tutorial Platform, a platform that helped a lot of students master chemistry and become a scholar in it. Now, on the board is writing of electronic configuration. Now, this aspect is a very critical aspect. We'll start with the definition of electronic configuration. This simply means the arrangement of electrons in an atom, and there are rules that are guiding the writing of the electronic configurations of elements. Now, there are two ways or two methods of writing electronic configuration. One, we have what we call the orbit method, the one that involves the KLMN, the shell method, and what we call the orbital method, which is the SPDF method. And this second method is the best method in writing electronic configuration. So when you as a student, you are asked in exam to write electronic configuration, it is wise for you to use this method I'm about to explain to you right now. Now we start with what are the rules? There are three basic rules in understanding, or three basic rules that guides the electronic configurations of elements. We have the first one, the Aufbau's rule. We have the Pauli's exclusion principle. We have the Hund's rule. Now we'll start by stating each of these rules and how they can be applied in this video lesson in chemistry. Now, the first one is Aufbau's rule. According to this rule simply states that electrons fill orbitals. Take note, electrons fill orbitals in order of increasing energy. Take note of this point. Increasing energy, starting from the lowest energy level, then it starts climbing. It's like a building up. You start from 1, from 2 to 3 to 4, as the case may be. Now, the next of the rule is the Pauli's exclusion principle, which I also call the electron pairing rule. According to this rule, each orbital can hold only 2 electrons, and these 2 electrons must be of opposite spin. Something like this, opposite spin. Not like this or like this. No, they must be of what now? Opposite what now? They must be of opposite what? Spin. Is that clear? Now, the last of this rule is the Hund's rule, which I also call filling orbitals one by one. According to this rule, electrons fill orbitals of the same energy level, one at a time, before pairing up. Now, this rule might not at this point now make sense to you, not until we go into it deeper. Now, be relaxed even as we go or advance in it. Let's go. Now, I will erase this so I can talk on each of them one after the other. Now, what are the things we should know? Now, for the orbital method, this is what you should do. When you make it of what we call the S, P, D, F, we also have the G, we also have the H. Exactly, we also have the G, the H, and that is how it climbs. The S, P, D, F. Now, this is what you should know. This is the according to the azimuthal quantum number, azimuthal quantum number. Now, for the energy levels are numbers. They are numbering. Exactly. I will make use of the energy level and the azimuthal to pair up together to give us a ladder of the electronic configurations of elements. That's grammar. Let me explain. Now, if I'm to do this rule, we'll be going in step by step. You'll be going from 1, 2, 3, like 1, 2, 3, 4, 5, 6. So it will be climbing like in this format. Is that clear? Now in the case of x, now we start with x, move to p. For x, we can only have one x. See the way, first of all, bring out this thing out. For they will start doing it 1, 2, 3, 4, 5 till you get to any amount, like any number. Now 1, we can only have one x. For 2 now, we're having 2x, 2p. You see it now? For 2 to be 2x, 2p. For 3 to be 3x, 3p. Then what next? 3d. For 4, it will be 4x, 4p, 4d, 4f. For 5, 5x, 5p, 5d, 5f. For 6, it will be 6x, 6p, 6d, 6f. We can also have from here now, where we have 3d, you can have 4x, 4p, 4d, 4f. For 5, it can be 5x, 5p, 5d, 5g, 5f, 5g. Now, if we are being able to do it like this, we can now begin to write it out. And by writing it out, what do? Please, this is where you must, if you have done it like this now, that is one point. And the next level is to be able to cross them, to be able to arrange them out in a simple circuit so that it can be solved. Now we come here for one, now you look at it. See the way I'm scrubbing my hand? Let's move this way, like this. Come here, like this. Come here, like this. See now, it will be, see the way I'm doing my hand. See, next one, this is, it ought to be like this. Let me, I come here again. So let me bring this one out. Here becomes 1x, 2x, 2p, 3x, 3p, 4x, 3d, and so on and so forth as it moves. You see it now? Now, you see the way I've done it now. This is what should be in your head. So we can still cross it like this. You must know this. This method is more preferable. 1x, 2x, 2p, 3x, 3p, 4x, 3d, 4p, 5x, 4d, 5p, 6x. Many a time in exams, I often advise my students, there is no point of you cramming this one. There is no point of you cramming this one. Reason be that there are times whereby you can forget this. But if you know how to form it, it is easier. It is easier. Now, if you understand this one now, we can now start to use this one as our template in writing configurations of elements. Now, I can erase this. Make sure you practice this. Now, we cannot go. We can now go as we continue. Now, we should understand that these are the energy levels and the azimuthal. Now, we should also understand that the maximum electrons of X, S can only carry a maximum of 2. P can carry a maximum of 6. Meaning if it is more than 6, right, you have to put 6, and if it is less than 6, it can go into P. If it is more than 6, it will have to go to the next orbital, right? The maximum of D is 10. The maximum of F is 14. We should take note. 2, 6, 10, 14. 2, 6, 10, 14. Now, if I'm asked to write the electronic configuration for oxygen now, which is 8. Remember, atomic number here is 8. So what do? Here becomes 1s. Remember, maximum of X here is 2. Right? Left with 6. 2x. S can also carry maximum of 2. It is not up to 8 yet. Now, 1x to 2x to 1x to 2x to 2p. Now, what is left from this 8? Is it not 4? So p can accept 4 here. Remember, this up here are the electrons. That's 2 plus 2 plus 4 is what now? 8. This is the correct electronic configuration for what now? For oxygen. If I'm now working with something like calcium now, that is 20. The configuration for calcium now, how do we go? We follow this pattern now. It will be what now? 1s2, 2s2, 2p6. Why? Because it's not, p can carry a maximum of 6. So I cannot put 7, or I cannot put the rest here. No. So 2p6, 3s2, 3p6. If we do all this now, it's left with 2 that is not remaining. So that 2 can go into this one, 4x2. So this is the correct electronic configuration for calcium. And that is how the pattern operates. Now, if I'm to go higher, for example, let's say I'm to work on vanadium. Vanadium is 23, which is 1s2, 2s2, 2p6. Just know this template. Just follow this template. 2p6, 3s2, 3p6, 4s2 is now left with 3, right? So it will now go 3d3, which is now 23. Now, please be very, very careful here. Be very, very careful here. Be very, very careful. Why am I saying this? The maximum of x is 2. Maximum of p is 6. Maximum of d is what now? Is 10. Meaning, if the electrons you have to add to each of the orbiter is less than that particular orbiter, it can go. But if it is more than, you have to put the maximum into that orbiter and take the other one that is remaining to the next orbiter. That is how it operates. Is that understood? Now, we've talked about the Pauli's exclusion principle. The Pauli's exclusion principle. We said that according to it, no two electrons must behave in the same manner, meaning that they should be of opposite spin. For example, if I'm having oxygen now, oxygen can have just one boss. One boss, p orbital, 3 bosses, d, 5 bosses, f, 7 bosses. It is from this one here we know that each of these orbitals can carry a maximum of 2, and that is why we multiply all through by 2. 2 times 1 is 2. 2 times 3 is 6. 2 times 5 is 10. 2 times 7, meaning only 2 electrons can go into each of these orbitals. This is one boss now. So here will be of opposite spin, meaning it will be like this. For 2x2, it will be like this. For 2p4, remember p can have 3 bosses. So what do I do now? I will have to, now, this is where Hund's rule comes in. According to Hund's rule, electrons must go into, like electrons fill each orbital singly, meaning one at a time before you can pair. You don't just pair at once. No, you don't just do something like this. 1, 2, 3, 4. No, it will be singly. In the sense, if I'm having 4 here, there will be 1, 2, and what now? 3. Then the remaining one that's remaining will not start from here again. Right? Now, if you are not asked a question here, how many unpaired do you have in here? You have only two unpaired. Exactly. Now, this is what actually explains this first part of this video. Now, our next video, we will not talk about the exception. There are exceptions. There are exceptions to this. And that is where you all should be very, very attentive. Do well to like, share, and subscribe. Thank you, and God bless you.